Good day, everyone. This is the PowerPoint presentation of Group 2 from BSME 3B, titled Project Gear. This is for the completion of our midterm project. Here are our group members: Argarin Loven Clinth, Bersabe Gerwin, Bilolo Christian Ivan, Deramas Fredrick, Dyke Jake Robert, Erlano Mary Rose, Hubilla Don Verbal, Labitag Ezekiel Henry, Madronio Michael, Nanale Pauline, and Natek Kristine. To present our objectives and the definition of a gear, may I call Argarin Loven Clinth.
Good day. I am Argarin Lovin Clean. Based from the instruction given to us for the project, we are able to identify the objective of this project. First, this project aims to identify what is gear and what are the possible application of it. This is important in order for us to understand what the project is really all about and we can apply it. Second, this project aims to conceptualize and design our own gear using different computer applications like AutoCAD. This is to master our knowledge in AutoCAD, which is also one of the goals of this subject. Third, this project aims to show the different isometric views of our own design gears. This includes top, front, rear, right, and left views. Fourth, this project aims to simulate the gear we designed using a computer application such as Fusion 360. Fifth and last, this project aims to use a spreadsheet in calculating necessary data for our gear designs. This will include computing for gear ratios, speed, torque, power, and efficiency. Now, let us proceed with our proper discussion. Before presenting our designed gear, let me define first what gear is. Based on our research, a gear is one of a set of two wheels that work together to alter the relation between the speed of driving mechanism, just like the engine of a vehicle or the crank of a bicycle, and the speed of the driven parts like the wheels. Basically, a gear is an equipment that is used for a particular purpose, such as increasing speed or increasing force of something. Gear is widely used in mechanical and industrial technology field, from our watches, vehicles, and machineries that use every day. Now, we know about gears. May we present the softwares we use in making our project? We have Gerwin Bersabe to discuss it.
And now, let's discuss about the software that we use to create our project design. So the first software that we use is the Autodesk Fusion 360. So Fusion 360 is a cloud-based 3D modeling, computer-aided design, manufacturing, engineering, and PCB software platform for professional product design and manufacturing. Fusion 360 also designs and engineers products how you want to ensure aesthetic, form, fit, and function. And it also creates anything with comprehensive electronics and PCB design tools. So the reason why we use the Fusion 360 for our design project is because it has a really complete collection of 3D modeling tools, making it quite easy to create solid models. Moreover, this software developed by Autodesk is really flexible and a bit easier to use, with a great push or pull tool allowing us to create great organic geometry and surfaces. With this, it allows us to save more time and obtain a quality-based model more quickly. Another software that we use is the Autodesk AutoCAD. The AutoCAD design and annotate both 2D geometry and 3D models as well, unlike Fusion 360 where it only lies on 3D modeling. AutoCAD also automate tasks such as comparing drawings, counting objects, adding blocks, creating schedules, and more. It creates a customized workspace to maximize productivity with add-on app applications and APIs. But some of us use this software to create the project as well. But majority preferred Fusion 360 because it is easier and more convenient to use. And now, let's proceed for our next reporter, Fredrick Deramas, discussing about the prototype.
So the first prototype concept was to design a simple gearbox using Fusion 360. The gearbox consists of a 4/16-teeth spar gears. So our first prototype was our first idea of how our gearbox will look like, considering some of the proper computations and other issues. The second prototype concept was to design a simple gearbox using Fusion 360. So a second prototype is the simplified form of how we solve some problems like how slow the first prototype is and other issues. So the third and final prototype was to design a simple gearbox using Fusion 360. Basically, this is the final concept without the crank. So it has a better accurate computation in image of how our gearbox will look like, considering all of the possible problems solved, including where it will be applied. So the concept of our gearbox, after having 3 trials, we have chosen the last or third prototype, which had the best and more accurate simulation of what our gearbox should be and the application of it in real life. So let's proceed to our next reporter, Kristine, for parts and perspective.
Hi, I am Kristine, and I am here to present the parts of our gearbox. Our gearbox is composed of shaft, case, crank, drive and gear, output shaft, and gears. Shaft refers to a component of circular cross-section that rotates and transmits power from a driving device such as a motor or engine through a machine. Shafts can carry gears, pulleys, and sprockets to transmit rotary motion and power via creating gears, belts, and chains. Case or gearbox housing is a protected casing which surrounds the components of a gearbox, providing physical protection and mechanical support for them. A crank is an arm attached at a right angle to a rotating shaft by which circular motion is imparted to or received from the shaft. When combined with a connecting rod, it can convert circular motion into reciprocating motion or vice versa. Drive and driven gear. The gear attached to the motor shaft is considered the first gear or the drive gear, and the other gear, whose feet are meshed with the drive gear, is considered the second gear. Output shaft. An output shaft connects the drive wheels to the automatic gearbox in the vehicle. The output shaft is the component that carries the power out of the transmission to the wheels. Spur gears. Spur gears are used to transfer motion and power from one shaft to another in a mechanical setup. These transference can alter machinery's operating speed, multiply torque, and allow the fine-tuned control of the system. Next, we will show you the different point of views of our gearbox. This is the front view of our gearbox in CAD. The second one is the front view of our gearbox in Fusion 360. This is the top view of our gearbox in CAD. And this is the top view in Fusion 360. This is the right view in CAD and the right view in Fusion 360. This is the left view of our box in CAD, and this is the left view of our gearbox in Fusion 360. This is the back view of our gearbox in CAD, this is the back view of our gearbox in Fusion 360. Bottom view of our gearbox in CAD, and this is the bottom view of our gearbox in Fusion 360. To present the components, may we call Christian Ivan Bilolo.
Hello, good day. I am Christian Ivan A. Bilolo. For the components of our gearbox, we will use steel for our shaft, which will technically be purchased, and we will also make use of 3D printed ABS plastics for the gears and case. For the faces, the physical material used are ABS plastics and steel, which will be white and steel satin in appearance respectively. For the bodies, the area is 1.831 plus 0.5 square millimeter. The density is 0.01 grams per cubic millimeter and 0.08 grams per cubic millimeter. The mass is 737.791 grams. The volume is 5.994 E plus 0.05 cubic millimeter. The physical material used are ABS plastic and steel, which will be also white and steel satin in appearance respectively. The next reporter will be Hubilla.
So I'm Hubilla and I'm going to discuss the computation for our gearbox. So there are two gear types used in making the gearbox. Gears A, B, D, F, and H. The small gears have the following properties: length of 27.004 mm, width of 15 mm, height of 27.004 mm, area of 382.695 square millimeter, and they each have 16 teeth with hole diameter of 8.5 millimeter. On the other hand, the bigger gears C, E, and G, have the following properties. They have length of 99.001 mm, width of 5 mm, height of 99.001 mm, and area of 7,151.348 millimeters squared. And they have 64 teeth with hole diameter of 8.5 millimeter. So we assume the values for the rotational speed of gear A as 131 revolution per minute and 20 Newton meter for the torque of the same gear, which is gear A. We also assume the gear efficiency at 85%. Given these values, we are to find the values of the following. First is the gear ratio of the whole gearbox. Second is the rotational speed of gear H, assuming gear efficiency is at 100%. Next is the ideal output torque. And next is the power of the gears in the box, assuming gear efficiency is at 85%. And lastly, the actual output torque. First, in solving for the gear ratio of the whole box, we use the formula gear ratio is equal to the quotient of the product of the number of teeth of the driven gears over the product of the number of teeth of the driver gears. As you can see in the formula bar of our Excel, gears B, D, F, and H are the driven gears, while gears A, C, and E, and G are the given driver gears. Thus, we get a gear ratio of 1:64.
Good day, everyone. I am Maros Ciala Erlano. Now we'll discuss to you the speed. After computing the gear ratio, we find the rotational speed, assuming that the efficiency of the gearbox is 100%. We use the formula by which ratio is equals to the input speed over the output speed. Since we have the gear ratio which is 1/64 or 0.05625 and assumed input speed which is 130 revolution per minute, we will substitute it in the given formula. We have the input speed equals to 130 revolution per minute over 0.015625, which will give us an output speed of 8,320 revolution per minute. After getting the output speed, we get the value of the torque. Since we've assumed that the input torque to be 20 Newton meter, we use it on the formula. From the equation, gear ratio is equals to the output torque over the input torque. We get the formula by isolating the output torque. The output torque is equal to the gear ratio times that input torque. By substituting the values we have, output torque is equals to 1/64 times 20 Newton meter. With this, we have the output torque value of 0.3125 Newton meter. Thus, the output torque is 64 times smaller than the value of the input torque. Let's move on getting the input and output power. Given the formula, power is equals to 2 pi times the rotational speed times torque over 60. By substituting the values in the formula we have, input speed is equals to the 2 pi times 130 revolution per minute times 20 Newton meter over 60. The input power is equivalent to 272.27 watts. By changing the context of the computation to get the value of the output torque, we assume that the efficiency of the gearbox is 85%. Thus, the output power will use the formula. Efficiency is equals to output power over input power. By isolating the output power we have, output power is equals to efficiency times the input power. Substituting the values we have, the value of output power is 231.43 watts. Lastly, as we use the 85% efficiency, we compute the output or actual torque by manipulating the formula. Output torque is equals to 2 pi times output speed times output torque over 60, which will give us the value of output torque of 0.265625 Newton meter. To check if the computation is right, we just use the formula of input torque times the 85% efficiency. And by inputting the values, we will have the same number given by the previous formula of output torque. Thus, our computation is correct.
You are currently watching the build process of the gearbox using AutoCAD Fusion 360 application.
The gearbox is the process of transmitting energy in a mechanical engine to increase the output torque or to change the speed of a motor. A motor shaft is attached to one end of the gearbox and through the internal gearbox configuration empowers an output torque and the speed determined by the given ratio. And now, you are able to see the individual parts of the gearbox with its following components: the shaft, case of the gearbox, the crank, driven gear, output shaft, and the spur gear.
We are now seeing the simulation of the gearbox, along with its different perspectives or point of view. The software used is Fusion 360. By means of manually rotating the crank in the software, the rotation is produced. An automatic simulation of the entire gearbox can also be achieved by the right-clicking joints and selecting Animate Model. Here are the different perspectives of the gearbox simulation.
I am Ezekiel Henry Labitag, and with the rest of the members of the group, would like to thank you for watching.